Welcome to the new chapter of derivatives. Okay. You already know something about derivative, that is d by dx. D by dx you have learned. If y is a function of x, okay, that means our x is input and y is the output. You know, x is the input and y is the output. If y is a function of x, okay, so this change in y upon change in x means if you do some change in x, if you perform some changes in x, how much change will be there in y? For example, if the function is y equals to x square, if suppose x is 2, then what will be y value? If x is 2, what will be the y value? If x is 2, how much will be the y? If you put x is equal to 2, how much will be the y? X is equal to 2, y will be 4. If you change x to from 2 to 2.1, what will be the value of y? So 2.1 square, that will be 21 into 21. How much 21, 21? 441. So 4.41, that will be the value of y. So if you change the x, there will be change in y also. So basically we have to find change in y upon change in x. But this is a big change. This is a big change. If you reduce the change in x, and that is called as dx. Okay, very small change in x, infinitesimal change in x, a very, very small change in x. How much will be the change in the y? The dx, instead of delta, we are using small d. Instead of delta, we are using small d. Hope I am audible properly. Okay, if any problem, tell me. If there is a change in x with a very small change in x, like if x is 2, now we are making x as 2.00001, like that, then what will be the change in y? This is called as dy by dx. This is called as derivative of y with respect to x. Derivative of y with respect to x. I have taught this in very detail in our physics sessions, starting physics sessions. All of you were there. That time also the derivative and differentiation I have taught you. Again, I am just refreshing your concept. Okay, since it is the start of the chapter, a very, very small change in x will cause a very, very small change in y. So that ratio dy by dx, that is called as derivative of y with respect to x, and sometimes it is also called differentiation of y with respect to x. Okay, differentiation of y with respect to x. Okay, right. So this is called the derivative of y with respect to x, dy by dx. So that is the chapter name. And in this chapter, we are going to learn how to find the value of dy by dx for different functions. Clear? Okay, note it down, please. Note it. Now let us continue our discussion. Okay, I told you that derivative is nothing but dy by dx, that is change in y and change in x. This also we discussed in graph also. We have discussed this in graphical plotting also. Suppose this is x and this is y. So if you plot y with respect to x, then suppose the graph is like, suppose it's you have studied the parabola x square equal to 4ay, this kind of graph, or y equals to x square by 4a, you can call it. That graph will look like this. Okay, now here also suppose you have the 2 points, one is the x1 and other is nothing but x2. Okay, or you can call one is x, another one is x plus delta x, like that. Okay, so that this one will be y and this one will be obviously this height will be y and that height will be y plus delta y. Okay, so definitely this change in y is this much. This is the change in y and this is the change in x. Okay, now we want to minimize this change in y and change in x. So we will bring these 2 points closer to each other. Okay, now if we join these 2 points, you will get a line, and that line is called secant. That line is called secant. A line which touches the curve at 2 points is called secant. A line which touches the curve at 2 points is called a secant. If we bring those 2 points closer to each other, then those 2 points will come closer like this and some further close, and finally they will become like a single point, and that final another line which is touching that single point to the curve, that is called tangent to the curve. That is called tangent to the curve. At that point, what will happen, that this delta x value will reduce very much and delta y value will also reduce very much. The points will come very close to each other. At that time, we'll call it as dy by dx, that is derivative of y with respect to x. Okay. So this diagram also you can draw, and then I will show you one animation also, how this delta y will become dy, how these 2 points will come closer to each other, and how the secant will become a tangent. Okay. Just note it down. Okay. So what is happening exactly is, if you have a curve which represents y is a function of x, okay, like y is equal to x square equal to 4ay, that is y equals to x square by 4a, and you have 2 points which are very far from each other. First point you are calling it as x, second point you are calling it as x plus delta x, okay, x coordinate of the second point, and the first point the coordinate is y, and the second point the coordinate is y plus delta y. So this distance is delta y and this distance is delta x. Okay, so if you bring those 2 points very close to each other, if you bring those points very close to each other, now if you join them, it will be a line which is touching the curve at 2 points and it is called as a secant. But if you bring these points very close to each other like this and like this and like this, then they will become a single point, and that single point, if you draw one another line, that line is called the tangent to the curve. That line is called the tangent to the curve. In the process of decreasing delta x, the secant has become the tangent to the curve. Okay, so the secant has become the tangent. Tangent is a line which touches the curve at a single point. The slope of the tangent, because tan theta is nothing but delta y by delta x, but now delta y has become dy and delta x has become dx. The slope of the tangent is called derivative of y with respect to x at that particular point. Suppose it is x1 comma y1. So at that x1 comma y1, whatever this tangent slope is there, that slope represents the derivative of y with respect to x. So I am writing here, slope of the tangent represents the derivative or derivative of y with respect to x at that point. Slope of the tangent at a point, slope of the tangent to the curve at the point represents the derivative of y with respect to x at that point. Please note it down, these things. Slope of the tangent to the curve at a point represents the derivative of y with respect to x at that point. Okay, note it down. Okay, slope of the tangent to the curve at a point represents the derivative of y with respect to x at that point. Okay, clear? Is it clear? Note it down. So now I will represent this derivative in the graph. Suppose you are talking about this point. So suppose this point is x now. The next point very close to this one. Very close. That is, so that's what x plus delta x. Now we have even brought it closer and it has become, at that point itself we are talking, right? So at that point we are drawing the tangent and we have to find the theta, the angle made by the tangent with the positive direction of x-axis, and tan theta represents dy by dx. Actually what we did is dy is nothing but y2 minus y1 and dx is nothing but x2 minus x1. Means provided limit. Now y2 minus y1 means we are saying uh, that means we are talking about x2 means x2 is x plus h, x1 is x. Suppose x1 is x, x2 is x plus h. Somewhat that limit you have learned, limit you have learned, limits you have learned, limit h tends to 0. That means h is very small. H is very small. Limit h tends to 0. H is very small. F of function of x plus h minus f of x, because y2 is nothing but f of x plus h and y1 is nothing but f of x. X2 is x plus h and x1 is x. So x plus h minus x. Okay, understand? Limit h tends to 0, y2 minus y1 by x2 minus x1. Y2 is f of x plus h and y1 is x, f of x, x plus h minus x. Do you understand this? This will cancel and this becomes one formula. This is called as, this is nothing but dy by dx. This is nothing but dy by dx, and this formula is finding the derivative by first principle. This formula is called the first principle. First principle, very important formula, and one full exercise is devoted to this formula. Okay, so please note it down, this one. Now we will do the questions on the first principle. Okay, so for first principle, questions will be like this: y is equals to x square. Y is equal to x square. Find dy by dx at x equal to 3, like that. Okay, what you have to do is that you have to apply the formula. Okay, what is the formula? Limit formula. Limit of h tends to 0. That means h is not 0 but is tending to 0. Its value is very close to 0 because the x plus h and the x is very close to each other, and the formula is like this. And here you have to substitute everything. F of x plus h means f of x is actually x square, so f of x plus h will be x plus h square. Limit h tends to 0, x plus h whole square minus x square upon h. The idea is that the denominator and the numerator should not become an indeterminate form. For that we have to simplify it first. So let us simplify it by expanding it and trying to remove h from the denominator. And if you take h common from the numerator, then this h will get cancelled from the denominator and you are left with limit h tends to 0, h plus 2x. And if you put the limit, your answer will be 2x, right? Now you can substitute the limit h tending to 0 and your answer will be 2x. So our final answer is 2x. So derivative of y with respect to x is 2x. But now you can put the value of x at the last. So 2 into 3, that is answer is 6. Answer is 6. Okay. Now we will do another question. Y is equal to 6x. Find dy by dx at x equal to 1. What is the procedure? Procedure is, first write the formula dy by dx, limit h tends to 0, f of x plus h minus f of x upon h. Limit h tends to 0, f of x plus h means f of x is 6x. So f of x plus h means 6 onto x plus h. So 6 into x plus h minus 6 into x upon h. Limit h tends to 0. Limit h tends to 0. 6x plus 6h minus 6x upon h. Right. This will get cancelled, and h also will get cancelled. So limit h tends to 0, 6. That is 6. So final answer is 6. Irrespective of whatever the value of x, final answer is 6. Okay. Now I will give you one question. Okay. You solve yourself and send me in WhatsApp. Y is equals to 3x plus 2. Find dy by dx at x equal to 5. Okay, this is your question. Whatever concept is there, same concept, apply that concept. And what is my idea is to check that whether really you understand the procedure or not, how to solve, where is the gap between my teaching and what is your understanding. Okay, so please solve it and send me now. Is it correct or not, that and all, don't worry. Whatever is coming in your mind, that procedure, that if you follow it and send me. Okay. This is how you have to write in exam. Okay.